In problem number 2, in section 6.2, we are asked to select letters from the word Mississippi, and in part A, to write the sample space. Well, the sample space, let's call it S. This is the set of all the possible outcomes. So when we start selecting some of these letters, what could we get? We could get an M, we could get an I, an S, or a P. Now, it doesn't matter that there's more than one S or there's more than one P or more than one I. It's just that when we go in and select, like randomly pick a letter and you pull one out, what could you get? You could get an I. This I and this I and this I, they're all the same I. So you could get an M or an I, an S, or a P. Now, in part B, we're asked for the event. Let's describe the event. I'll call it E, and it's a set. The letter chosen is a vowel. So what could we get here? What are the vowels that we could choose? Well, there's only one vowel here, and that's the I. So this event consists of the element I. And in problem number 3, we're told that an experiment consists of tossing a coin 2 times and observing the sequence of heads and tails. What's the sample space? This is part A. What's the sample space for this experiment? So sample space, this is the set of all the possible outcomes. Here's everything that could happen if you toss a coin twice. You could get a head on the first and a head on the second, or you could get a tail on the first and a tail on the second, or you could get a head on the first, a tail on the second, or a tail on the first and a head on the second. Now, I put in these subscripts myself just to keep track of which toss is which, but you probably don't need to because they're in order: head first, second, first, second. And in part B, we're asked to describe the event the first toss is a head as a subset of the sample space. Well, this is going to be this event here. So just look back up to the sample space and see which first tosses have heads. This one here and this one here. So we can just write that. We could get a head on the first, a head on the second, or we could get a head on the first and a tail on the second. Now problem 5 tells us that we have 2 urns, urns 1 and urn 2. Now remember, urns are just boxes. And each urn contains red balls and white balls. So what we have in here now are red balls or white balls, red or white. We're not told how many, just that we have red or white. Now here's the experiment. First of all, we select an urn and then select the ball from that urn, and we note its color. So select an urn, then select the ball from that urn and note its color. So we are asked to write a suitable sample space for this experiment. So how about S equals? Now here's what could happen. First of all, you select an urn. So suppose we select urn 1, and then from that urn you select a ball and you note its color. So we could get urn 1 and a red, urn 1 and a white, or we could have selected urn 2 and then get a red, and urn 2 and then get a white. And part B asks to describe this event, and the event is urn 1 is selected. So urn 1 selected, that could give us this one, could get a red or a white. Nothing over here. All right, so we could get urn 1 and a red, urn 1 and a white. Now in problem 12, we are given this set, this sample space, and these 3 events. So E is getting a 1 or a 2. So if a 1 or a 2 shows up, E occurs. They don't both have to show up. We do the experiment maybe once, and if a 1 or a 2 shows up, then E occurs. F will occur if you get a 2 or a 3, and G will occur if you get a 1 or a 5 or a 6. So part A asks us if the events E and F are mutually exclusive. Now, 2 events are mutually exclusive if E and F are empty. So if the intersection is empty, then E and F are mutually exclusive. So let's look at E and F in this case. So here's E, here's F. Now if 2 shows up, then both E and F occur. So for this problem, we're going to say E and F, that's not equal to the empty set. So the answer to this question is no, they're not mutually exclusive. And mutually exclusive, let's keep in mind you can interpret that as if one event occurs, the other one cannot. Now, if a 2 comes up, that means E has occurred. But also, if E occurs, F could still occur. Or if F occurs, it's still possible for E to occur. And part B asks us if F and G are mutually exclusive. Now here's F, 2 and 3. Here's G, 1, 5, and 6. There's nothing common to these two sets. So if a 2 or a 3 shows up, if you perform this experiment and get a 2 or a 3, you can't be getting a 1, 5, or 6 at the same time. So these two events, E and F, these sets, the intersection is empty, and the answer here is yes. These two events are mutually exclusive.